thank you all for taking time off your busy schedules and being here in this conference on digital transformation for digital governance. Governments from Tokyo to Seoul are in the midst of a historic transformation as they abandon analog operating models in favor of their digital counterparts. The local and state governments are at very different stages in their journey of digital transformation. Only a small percentage of the various state governments are maturing, while the overwhelming majority of them are still in the early or developing stages of the journey. India is no different. Although different state governments would be at different levels of digitization, the country as a whole has a strong focus on Digital India and is aggressively giving shape to its digital transformation strategy. From automation to using IoT, to make cities smarter, the local, state, and central governments are using technology to improve their citizens' lives. Therefore, to acknowledge the efforts put by state governments and highlight their achievements in bringing the benefits of digital to their citizens, Economic Times CIO and Microsoft have joined hands to organize this event. We hope that the discussions over the next few hours will add a lot of value for all the participants and further motivate all the stakeholders in their quest for digitally transforming governance in Uttar Pradesh. So without any more delay, I would request Mr. Prashant Shukla, National Technology Officer, Microsoft India, to please come up on the stage and deliver the keynote address. The topic of the address is Digital Transformation Using Artificial Intelligence and Machine Learning. Over to you, Mr. Shukla.
A very good evening to all of you. Over the next little bit, I plan to do two things. First is to actually talk about some of the things that are going on in the industry, but the second part of it is to actually show you how the cloud works. And for that, I've got my internet stable over here, and I'm going to actually take you through a cloud presentation and show you how the cloud actually works. I'm sure you've heard about machine learning and artificial intelligence. You've heard about the bot frameworks and the virtual bots and so on and so forth. Well, just keep that thought in your head as we go through this presentation, because all these I will show you before we end this session. So without much ado, let me just quickly introduce. I just wanted to take 30 seconds to tell you that this is an amazing time in India. No matter how you slice and dice the data, the economy is all set to grow in an amazing way. And I won't go into all these numbers, but no matter how you look at it, 4 trillion, is the size of the economy that is anticipated in a few years. You look at the number of startups, the number of innovative steps that are going on. And here the role of people sitting in this room, the people who are involved with e-governance, that needs to keep pace with what is going to happen in the rest of the industry. So the new technologies that are coming up are something that you have to embed yourself in. If you don't, then there is a huge disparity between what the people will be expecting of you and what would be possible. And I'll give you some examples of how easy it is to do it if you're aware of the power of the new technologies that have been enabled through the cloud. There's a very interesting slide that I thought I'll share with you, but in essence, the world has become one giant network. And you're dealing with data at the sizes that has never been dealt before. In fact, what they're saying is about 30% of the world population will be online. And you're talking of about 2.5 billion people, twice the size of India, who will be online at any given point of time. 44 zettabytes of data. The mega and the peta and the tera are all gone. You are talking of zettabytes, and even that is not enough, because as they're looking at the future, they've come up with a new number called utabytes. How many of you heard that term, the utabyte? So utabyte, I've got at least a few people over here who've heard this. The anticipation is that the data at the edge, the data through the IoT, the data that will be created at the edge is going to be so large that if you start creating hard disks, you will cover up 3 states in US. In other words, you keep stacking up these hard disks and you will cover the area of 3 states in the Northeast, New England, Rhode Island and all that stuff. So that's the size of the data that you're talking about. What is Microsoft's play in it? It's about three key things coming together. The first is reinventing productivity. The second is looking at personal computing in very much more meaningful ways. But the most important part is about figuring out how the cloud intelligence, that humongous data center which has so many more capabilities that are otherwise possible to describe, how that brings insight into data on the edge, in your environment, in your desktops, in IoT devices, in God-forsaken places. Think of this humongous data center that is sitting here and how it brings intelligence into the edge. To give you a sense of the size of some of these data centers, you start thinking large, and you think that some of these data centers are so large that you could park 2 jumbo jets inside them. You take one jumbo jet and park it inside, and you take another jumbo jet and park it inside. That is the size of some of these data centers where this amount of compute is being put. To give you a sense of how these data centers are constructed, to put through that in your imagination, imagine blocks that have 22,000 cores. Now your ordinary desktop has 4 cores. So think of machines that are so large that could have 22,000 cores by way of processing systems. So that's the size that you're talking about. Now the first question that comes in your mind is, why do you need a Microsoft or any of our competitors for that? Why do you need their data center and not your private data center? That is a natural question, and it's a valid question. And the answer lies in living in a world that connects the two. Why do you need those existing services on the cloud? It is the exact same reasons why it is very impossible to build a jumbo jet. But you can still have small planes. You can still fly small planes. But it's very hard for individuals or companies or groups to build jumbo jets. It's the exact same reason. If you see this slide, you will realize there are so many services that are coming online every week, every bi-week, and every month, that it is impossible for any private data center to build those services in their data center. That is why the cloud is so powerful. It is not just setting up virtualization, which most people call as cloud. That's not the point. It is the fact that the data centers have ready-made services. And before we end this session, I will show you some of those services right here. So the other question that comes in our mind is security. What happens if the data is on the cloud and how secure it is? And this is one area where I'm ready to have an argument with anybody. The public cloud is far, 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 far more secure than what can be done in any private data center, period. It is not possible for most people to build that kind of security in their data center simply because of 4 key reasons. One is the way the cloud has been architected itself. Now I'll just share one concept, otherwise I could go into security and speak about it for 2 hours and we'll be all sitting here. But I'll just share one interesting concept. It's called micro-segmentation. Most private data centers are all about putting up DMZs, demilitarized zone, and a firewall. Once you break through the firewall, you are inside the system and the malware can sit in your system for days. On an average, malware has been shown to sit in most private environments for about 90 days before it is even discovered, before it is even seen. And I've got a gentleman over here who's going to talk about the cyber security threats in a bit, and he'll tell you all about it from a police perspective. But that is the size of malware that sits because of the way the perimeter security is dealt with in most private data center. In the cloud, there is a concept called micro-segmentation. Every application runs in its micro-segment and has a firewall between this application and the next application. So if you put it simply, it is like when you come into this Novotel hotel, once that security guard in the front has allowed you in, you can pretty much enter wherever you want. You can enter this room, you can enter that room, you can enter that room. What microsegmentation in essence says is, yes, you have come in through the door, but every room has its own security that delineates it from the next room. Microsegmentation. Not possible in any private data center, and this is one of the main reasons why there are security breaches in private data centers. Because what happens is, the malware comes in, it first goes and stores itself in a very low priority machine, and then quietly sits there, sniffing what is going on in the network. One fine day, it attaches itself to some email, which is going to a senior level person. Maybe it's the CIO or the executive or the vice president, and goes and attaches itself innocuously. And when you click that, it takes itself as a system thread. And at that time, it has access to the entire environment. And it does, I'm sure you've heard of this virus called Wannabe that encrypted all the data and put a lot of companies to ransom, or a lot of governments to ransom. So much so that it's not just India. There is public information about one of the large government departments in UK. I think it was the National Health Services, if I'm not wrong, whose data was encrypted. Am I right? It was National Health Service, whose data was encrypted, and they said, you pay us this much money, otherwise we'll not open it up. So microsegmentation is just one part. The second part is the amount of investment that Microsoft makes as a company versus what private data centers can. The easiest example is $1 billion in just security. These are the people and individual and resources that are only getting up in the morning and doing security. Third, we have something called Azure Key Vault. What that means is all data in motion and all data at rest is encrypted by keys that have been created by you, and that is just one part of it. The delineation of the test, development, and production environment. So what happens is, in Azure, you create these keys, and the URI gets pointed to different locations in your application. That key is different for test environment, dev environment, and production environment. What does that mean? The control is given to the people, and the access of the data is given to the people as desired by the organizational hierarchy. If, for example, in many of your cases, you have a government data center, and you might have a private party that is running the data center. You might have the equivalence of, one of the Indian SIs, could TCS, CMC, Wipro, any of these SIs. Rather than enabling production system access to any of these, people who have set up your system, you can set the keys so that the production environment is controlled differently than the test and the development environment. Simply put, in the private data center, system administrators are God. In cloud, there are no gods. It is an access-based system that you need to do it. So I can keep on going on security, the monitoring, the logging, the process for security, the process we put on who will touch the data, the video surveillance that are put for anybody who goes into the data center, and all the enchilada. But the net of it is, public cloud is far, far, far more secure than anything that can be done in a private data center. And the testimony lies in the way, the breaches are being handled all over the world on the cloud versus not. So I told you some time back about this very interesting picture. When you're talking of the PCs, you're talking of a few 100 million PCs. And then you went to the mobile client-server environment, and you started talking of hundreds of thousands of servers. And then you went into the mobile environment, and you say now India has 1 billion devices and China has 1 billion devices. So 7 billion people in the world. At best, if everybody has 10 devices, 10 cell phones or 10 personal devices, then also you are talking of 70 billion devices for the entire world. Now that may seem like a large number, but once you start talking of the edge, the IoT, you are talking of trillions. And the data that they are producing are an order of magnitude more. So I was talking of that yottabyte number. The reason why they are thinking of yottabytes as the new dimension is because of the size of data that will come on the edge. So without much ado, let me just actually show you some kind of new devices that are coming up. How many of you here have seen these new experiences that are data rich and that have now been enabled by technologies such as HoloLens? How many of you have heard of HoloLens? Okay. So I'll give you this experience which actually creates augmented reality for you. When you walk in the room wearing a HoloLens, it seems as if there are other things that are added to things in front of your eyes by putting augmented reality in front of you. So let's show you
Look
this.
around.
Can you
Technology
dim the
is
lights?
all around us. We use it in every aspect of our lives. It enables us to do amazing things. But what if we could go further? What if we could go beyond the screen? Where your digital world is blended with your real world. Now we can. This is the world with holograms. What will they enable us to do? New ways to visualize our work.
I have an idea for the fuel tank.
New ways to share ideas with each other.
How are things going your end?
I just put the images in OneDrive.
Perfect.
More immersive ways to play. New ways to teach and learn.
So put the new trap in the place of the old one.
Now what?
And tighten here and here.
New ways to collaborate and explore the places we've never been.
Look at this formation. Let's take a closer look.
And new ways to create the things we imagine. Because when you change the way you see the world, you can change the world you see. This is Microsoft HoloLens.
So there you have it. Imagine the scenarios that are possible in many of you who are building bridges, in many of you who are constructing, in the manufacturing area, in many of you who are trying to do operational maintenance of very expensive assets. If you were, for example, putting up a power plant, people from UP Electricity Board, if you're putting up power plants, where will a device like that can let you see that thing without physically being there, virtually see that thing? That's what HoloLens offers to you. So the next one that I'll show you is about machine learning and what it has to offer. And for that, let me just first show you a nice video that actually shows this application.
It used to take 2 weeks to sequence and analyze a genome. With the Microsoft Cloud, we can analyze 100 per day. Whatever I can do to help compute a cure for cancer, that's what I'd like to do.
So the genome sequences are billions and trillions of bits of information in your body. They define how we look, how our eyes look, how our colors look, what is our nose shape, and we inherit it from our parents. There's also research that says that there are a certain set of individuals with certain genomic sequence who are prone to certain diseases or not. Now in the old days, it used to take, months, if not years, just to analyze one genome sequence. So if I wanted my genome sequence analyzed, it will take that much time. Today, you heard this gentleman from Virginia Tech. He said that even with the highest high-performing computing systems, it used to take him an inordinate amount of time in trying to get the genome sequence done. Today, he does 100 genome sequence a day. 100 genome sequence a day. That is the speed, and when I was telling you about these cloud data centers that are so large that you could park 2 jumbo jets inside them, that is what I'm talking about. That is where you need those intensive computes and thousands of cores in order to be able to do that kind of analysis that quickly. So this is one example, but let me tell you another very interesting innovation that is going on the personal computing side. New devices are emerging that are a lot more user-friendly. How many of you here have heard of Microsoft Surface? Some of you? Have you tried it? Have you used it? Yeah. So you will find that it is very pen-friendly. You can actually write on it. You can sign on it. In fact, I was thinking there should be a way in which instead of government files moving on physical paper, it should be just possible to sign on that sheet itself, on the surface, by building an application, and the file just moves. So you don't have to have somebody carry this physical piece of paper and print it out and all that stuff. And it looks exactly the same. The signature that appears on the surface is so smooth that if I sign a paper, print it out and send it to you, you won't be able to distinguish whether I have used a pen or not. It is so good. And besides, what's in a signature on a piece of paper versus on a machine? It's identical. Ultimately, it's the strokes that you're putting that matter. So without much ado, let me just show you this. And this is another very interesting example. Put up the sound, please. Anybody here from PWD department? Water? Oh, there you are. Water resources. So you're next. I'll show you this. But the point that I was trying to make was, the fact that these new devices are possible, the drafting that you do, the drawing that you do, the error corrections that you do, that you used to do in the old world in drafting sheets. I remember my Technical Arts 101 where you had these large drafting sheets and you were drawing scales on it. That is all now possible with the same finery in new devices. And it is better because if you make an error, you don't have to revert to the new drafting sheet. You can actually just erase it electronically and just redraw it. And replication and multiplication, all those things are so simple now. So it is time for all of you to start thinking of how you will advance your departments or the new people who are coming under your leadership. How will you train them to bring up to this concept of digital India that our Prime Minister and our Chief Minister and everybody else is advocating? That experience is far easier and simpler. Trust me, computers are a lot more user-friendly. It's almost like switching light bulbs in your house with a little bit of practice. But it does require a change of mindset, because what the mind will think, the eye will see, and the brain will learn. If the mind does not think, your hands and the rest of your body will not learn it. So I saw a lot of hands from the Water Resources Department. Anybody from Water Resources? I thought it'd be interesting to share with you a very interesting example of a cloud application which has been enabled through water resources. Now, some of you are involved with river cleaning and water pollution management and so on. And if you see the river Ganga and the Namo Gange plan that has been going on for quite some time, one of the challenges is not that the river is dirty. It is that the pollution is inducted in it. I said cleaning the river is a very simple process. You don't throw pollution in it for just 1 month. Just 1 month. Don't throw any stuff inside it and it'll be clean, because the water will just flow through. It'll go from Gangotri to the Bay of Bengal and the water is clean. The problem is the pollutants and the polluting agencies. So this particular example that Microsoft has done, along with one of its partners, is about actually stabilizing a buoy real time as a part of our work with Pollution Control Board, putting SIM cards in that buoy and sending the pollution data real time to the cloud, from which it can be seen anywhere in the world. You can sit here and take your mobile phone, log on to this website, and start seeing how the pollution levels are in the river Ganga, in different locations. Is it everywhere? No. Can it be made available everywhere? Of course, 100%. We've actually shown it. So the way it works is, you can see these actual physical devices. The buoy is actually put like this in the middle of the river, and it starts to monitor a whole bunch of parameters, which I can go on. The people from Water Resources body will understand this data far better than I can. The COD, BOD, TOC, these are terms that are very common to you. I am an engineer, I probably don't understand half of it. But pH, conductivity, dissolved oxygen. Is this data important to all of you? What do you think? Yes? Imagine if sitting inside the comforts of your room on a night, on a cold wintry night, and they are arriving in Lucknow. It's already becoming cold. Imagine if you could see this data right here. And imagine if one of your industries that is responsible for pollution does its pollution or does effulgences that increase the pollution level, and in less than 10 seconds, not 10 minutes, not 10 hours, in less than 10 seconds, you get a notification on your mobile phone saying that at this location, the pollution level just went up. And imagine if real time you could send an inspector and catch them and penalize them a couple of times so that they don't do that again. That will have the possibility of cleaning water. Another example, water that we all drink. Water coming from Lucknow Municipal Corporation. Do we really know time to time, minute to minute, what kind of water is coming to us? We believe it is clean. Absolutely, no doubt about it. But time to time, minute to minute, hour to hour, day to day, do we know what water we are drinking? And that's the water that you are drinking and your family is drinking and your cousins are drinking and your children are drinking. Would it not be reasonable to say, Lucknow Municipal Corporation must be spending, I don't know how many crores in water management. This devices cost in lakhs, maybe 2 lakhs, 3 lakhs, 4 lakhs, something like that. It's not even rounding off error. By just using this digital technology, it gives you a sense of how much pollution level there is in the water, whether it is potable or not, or if it is not, what action do you take? So this is an example. These are where the buoys have been monitored. This is the data that is coming real time from Bangalore Water Supply. Bangalore Water Supply has implemented it. If Bangalore Water Supply can do it, why is it not possible to do it in UP? What is so big about Bangalore that they can do it and we can't? Of course we can, right? But it's a matter of that mindset where you're saying this water that we drink is so important to us. Today, modern technology can make it happen for you. And I'm just giving you one example of it. This is how the monitoring system looks like. So with that as a specific example, let me take you through some very interesting experiences here. And the first of this is about machine learning. So what I'm going to do is show you how predictions can matter. And here I've got all kinds of examples in machine learning. But here what I'm doing is I'm taking a whole bunch of data. Just so that you know, the basic idea behind machine learning is you take a humongous amount of data. It can be about cybercrime. It can be about financial frauds. It can be about maintenance, predictive maintenance of your equipment. If you have a bus, if anybody is from UP Transport Department, or if you have a car, or if you have a bridge, or if you have a factory, or if you have a plant, predictive maintenance of equipment. What that means is before the equipment fails, it should be possible for you to predict which part is going bad and take care of it real time. That is the power of machine learning. Today we are doing it with Rolls-Royce engines. So imagine these planes that fly and they have these huge engines that you put there. And imagine now these Rolls-Royce engine emitting huge amount of data. You take that data and you predict this particular part is prone to failure, change it before the plane takes off from the ground. That is what predictive maintenance is all about. So without much ado, I'm actually going to show you on how I will log into my cloud account. And I thought about it and I said what would be very interesting from your perspective is to actually see how this thing works. Rather than telling you all the science, it's like describing an elephant. You can tell it has a tail, it has a body like this, and its side is slightly rough and the legs are round. Rather than that, I thought I'll log into my cloud account and actually show you the cloud. So here we are. You can see the screen. If you look at the URL, it says studio.azureml.net. And here I've actually built a predictive model to predict the price of cars. And just for the heck of it, you will see how easy it is, because what I have here is the data of the car. So I'll just show you what that data means. I'm pulling this right off the cloud. So while this is coming up, let me just go through another experiment that I had in mind. So here I put up a website, and this is my website, and it shows examples of things that I have done. In order to set up this website, it took literally 30 minutes. I just set it up on the cloud and ran it over here. But setting up the website may be easy or may not be easy. But adding new services such as bots is very hard. So just for the heck of it, you will see over here I have a chat bot, which is a virtual agent. All of you have customers. The water supply department has all kinds of customers who say, I want the information about this. I want information about this. The transport department has a whole bunch of customers. The electricity board has a whole bunch of customers. And there's a phone that is constantly ringing in front of some customer service agent. What if that process could be automated, where there is a virtual customer service agent called the bot that answers all these questions, and there is no human being required. It is easy for them to do work that is more important, and it's a drudgery to answer these questions. And in the meanwhile, if you post it on the website, people can't find it. So here is an interactive bot, and because these days I am on a health fad, I built this bot literally in a couple of hours, and just to show that this is real code, I'll log into my account, and I'll actually make code changes right in front of your eyes. So here you have it. I have called this an Anand sandwich. And you can say, so it says, I want an Anand sandwich. It says, how long is this? So I say, this is like Subway. And everybody's gone to a Subway once in a while, right? Aapne dekha hoga. There's how many grains do you want? What do you want it, wheat or this thing? Then I say Monterey cheddar. And it says, what is your selection? And it says, what kind of, sauces do you want? And it says, is this your selection? Suppose you say, no, this is not my selection. Then it goes back again. What do you want to change? In a sense, instead of having a drab front end that is hard to deal with, you can set up these virtual bots that can answer most of the frequently asked questions for the customers automagically. On your website, nothing needs to be done. An example of that is, when is your house tax due? How much is my water bill? Who should I contact to pay my water bill? Can you direct me to a location where I can pay my water bill? My house number is X, and this house number has Y as the meter number. What is my water bill? All those things could be automated and made so simple. And just to show you how easy it is, I'm actually going to open a bot. So here you saw that bot that is running, and you can see this says PR bot PR, Prashant's bot. I just named it easily. And what I did is I opened up the console, and here you can see the sandwich application. So here you can see Anand sandwich, right? I'm going to change this and call it, Sandeep sandwich. And I'm going to call this Manmeet. And once I've saved it, I'll compile it right in front of you. So I'm going to build it. I'm just showing you the power of the cloud. All this is running on the cloud. I'm sitting here, standing here in front of you, and I'm doing this real-time compile and publishing it to the cloud. So if I'm right, and if the internet works, all this Anand sandwich and the other sandwich will change to Sandeep and Manmeet. So it's going to install a Kudo sync. It's taking this code change, pushing it real time to the cloud, syncing up, compiling it, and publishing it. And let's see how long it takes. Almost there. So here I'm just dependent on the speed of internet, and I'm finished. I'm done. And at this stage, if I go to this website and I refresh the page and I say hi again, and you can see there is a Sandeep sandwich and a Manmeet sandwich. Okay? So this is the power of the cloud. This is how fast you can do it. How much time do I have? Almost there? Okay. So let me just quickly wrap it up. I showed you this machine learning experiment. I will open up this Excel spreadsheet. I've already set up that experiment there. It has been published as a web service, and it will be consumed in my Excel spreadsheet. So in your case, if you are predicting your budgets, or if you are predicting your spends, or if you were finding out which part is faulty, the Excel spreadsheet could be running on your system, on your laptop, while the service is coming from the cloud. And just for the heck of it, I'll just show you how the prediction works. So you can see this, the prediction has come. That is how fast it is. That is the power of cloud. That is why it is so important for you guys to understand it. There's one other thing that I wanted to show you, and then I'm pretty much done. So what I have also done is something called the face APIs, recognizing whether a person is happy or unhappy or what is your age. So if I take a picture of this page of the people sitting here and I start predicting just by looking at their face, what's your age? Are you smiling? Are you wearing glasses? And for people like me, are you balding? You can even use face APIs that are available on the cloud as ready-made clickable services to predict that. And just for the heck of it, let's just do it. So I'll go to my account here and browse. And this is a meeting that I had with our Honorable Prime Minister. And you can see this is detecting. And there, it has detected. So it has detected two faces and marked them. Anything that the camera is facing, it has detected them. And watch what happens. If you read below, you will see it is the face of a male, smiling 100%. They're wearing glasses and so on. Can you read it at the bottom? I'm sorry, the script is small, but hopefully some of you can see it. Can you see it at the bottom? And then if you see our Prime Minister's face, you will see his age has been almost correctly predicted, 63 years. I don't know if that's accurate or not, but I guess that is about the age that he is in. But I'm sure some of you can go on the internet and find out exactly what his age is. But that's the power of ready-made components on the cloud. To build this application, it took me no more than an hour. 1 hour I had written this application. That's how fast it is. Last one, this is about speech recognition, and I found this to be very easy. And for many of you who are interested in development environment, and I see Sailesh and some other people, this is Visual Studio. Yes? No? Do you agree? I'm not making anything up here, right? So what I'm going to do is I'm going to compile this application. I'll just rebuild the solution and I'll stop my debugging. And we'll do it right in front of you. And you will see when I speak, it will take that speech, sample it, send it to the cloud real time, translate that, and send that English into Hindi right in front of your eyes. If this works correctly, which it does. So it says this is in English, the language is Hindi, and it will be the, I'll just start here. So you will see it is connecting, and it's connected. Today is a hot day. It is connected. Today is a harsh day. Yeah, it is translating correctly. So the internet is slow, otherwise it'll take a little more time. But you saw I built this entire app called a service. How many of you have heard of software as a service? Some of you have heard about it? Software as a service. This is software as a service. You're calling a service from the cloud onto this desktop, taking the data that I am supplying. The data here is my voice. It is sampling that data, sending it back to the cloud, changing text to speech, and sending it real time back. That is how fast this application is doing. So I'll stop here. I don't have enough time over here. Otherwise, I would have shown this app also over here. But those are all the things that I wanted to show you and leave you with this 3 messages. The cloud brings scale that is not possible otherwise. You saw the example of genome sequence. Billions of bits of information that can be analyzed 100 times a day. They used to take a year to do it. Scale. The second is ready-made services. It's like going to a shop. You can make sweets in your house. आप पूरा जितना भी 56 भोग का मिठाई है वो घर में भी बना सकते हैं. But when you go to that shop, you just pick up that piece and start eating it instead of getting atta and putting sugar and so, ready-made services, software as a service. And the last part is security. Doubt it not. The public cloud, and I can vouch and speak about Azure, the measures we take for securing our Azure cloud is second to none. It's extremely, extremely, extremely secure, not possible to do by many of the private data centers because the processes are not that big. The amount of investment that we make, the precautions that we take, the real-time monitoring that we are doing, all those are fairly significant. So I'll stop here, and I guess thank you very much.